Hi everyone. In this video, we are beginning section 2.5, which is about measures of the center of the data. When we collect data, one of the first questions we usually ask is, what is a typical value? For example, suppose I tell you that 4 students earned quiz scores of 12, 14, 16, and 17. You might naturally wonder, what score represents the center of these results? Or maybe what would be considered a typical score? Questions like these are exactly why we use measures of center. A measure of center gives us a single number that describes the middle or typical value of a dataset. Instead of looking at every number individually, we use measure of center to summarize the data with one representative value. In this section, we are going to study 3 measures of center: the mean, the median, and the mode. Even though all 3 describe the center of a dataset, they do it in different ways. The mean is what most people call the average. It takes all the values in the dataset into account and finds a balancing point. The median is the middle value after the data have been arranged from smallest to largest. You can think of the median as the value that splits the data into 2 equal halves. Half of the observations are below it and half are above it. The mode is the value that occurs most often. The mode tells us which value appears most frequently in the data. Now, here's something important. These 3 measures do not always give the same answer. Different data sets can have different shapes, and sometimes one measure describes the center better than another. Over the next few videos, we'll learn how to calculate each measure and understand what it tells us about the data. Today, we are going to focus on the most familiar measure of center, the mean. The mean is the average value. When someone asks, what is the average test score? They are usually asking for the mean. The mean is found by taking the sum of all values and dividing by the number of values. In simple terms, add everything together, then divide by how many values there are. Now, before we start calculating, let's think about what the mean actually represents. Imagine that 4 friends each contribute different amounts of money to buy pizza. Maybe one person contributes more and another contributes less. If we collected all the money together and then divided equally among 4 friends, each person would end up with the same amount. That equal amount would be the average contribution. That's essentially what the mean does. The mean spreads the total amount evenly across all observations. Because of this, we often describe the mean as a balancing point of the data. Now, let's look at the formula. For sample, we use X bar. For population, we use the Greek letter mu. X bar equals the sum of all X values divided by N. Now, let's talk about what those symbols mean. The symbol X bar represents the sample mean. The symbol N represents the sample size, or the number of observations in the sample. This Greek letter sigma represents the sum. Whenever you see sigma, think add everything together. So sigma x means the sum of all values in the sample. Now, for the population, mu equals sigma x over uppercase N. Mu represents the population mean. Sigma x means the sum of all values in the population. And the uppercase N is the population size. The process of finding the mean are the same. The only difference is the notation. Now, let's work through an example together. These are the quiz scores of a random sample of 4 students. One earned 17, one earned 16, one earned 14, and one earned 12. And we want to find the mean quiz score. This is a sample, so I am going to use this formula, x bar equals the sum of x over n. The sum of x means that I'm going to add everything together. I'll take 17 plus 16 plus 14 plus 12. N is the sample size. How many quiz scores do we have? 1, 2, 3, 4. So N is 4. 17 plus 16 plus 14 plus 12 is 59. And 59 divided by 4 is 14.75. So the sample mean of these 4 quiz scores is 14.75. Now, let's stop for a moment and think about what this answer means. Notice that none of the students actually scored 14.75. The scores were 17, 16, 14, and 12. So where did 14.75 come from? This is completely normal. The mean does not have to be one of the original values in the dataset. Instead, it represents the average or balancing point of the data.